Hello, everyone, and welcome to Science Explosion. My name is Zach, and I am coming at you from Hudson Public Library. For anybody not in Hudson, that is in Hudson, Iowa. Uh, so, welcome, everybody. I am excited to be coming at you with this Science Explosion. This week's theme is water, specifically the water cycle. And of course, as always, I've got my trusty water bottle here with me, and I'm going to take a drink. Alrighty, so let's start with the basics here. What is water? So I find it kind of funny that this is something that's so central to our lives. So by that I mean it's so much a part of our lives, but a lot of times we don't think about it. So the technical name for it is dihydrogen monoxide, or you've probably heard it called H2O. So that is two hydrogens and an oxygen, and it makes up liquid form usually when we have it. Although, who can tell me what the solid form of water is called? That's right, it's ice. Now, who can tell me what the gas form of water is called? That is right as well. It is steam. So we've got a name for the solid, liquid, and gas versions of water because it's so important to us. We have a specific name for all of them. And knowing those different things is going to be really important to knowing about the water cycle. So you might have noticed what I've got behind me already. So I've got our little hot plate and a pot back here, and I'm going to fill it with water and start heating that up. Alrighty, so gonna turn on the water here. You don't need to measure it if you're following along with me. There we go. I don't need a ton. So I'm gonna set that on here and turn it on to high. All right. So if you'd like to follow along and do this yourself, you can. This part is not an experiment. It is a demonstration. So we're not going to be finding out anything really world-changing here about it. But I think it is still nice to be able to see what we're talking about while that's going. So that's going to take a few minutes for it to go. The reason I turn it on high is because I'm going to be bringing that to a boil. And anybody who cooks very often is going to know exactly what that means. But I'm going to talk about that in just a little bit. All right, so for our experiment today, it's going to be real simple. You're not going to need a whole lot of materials for it. So the first thing that you will need is a baggie. So I just have a plastic baggie here, but if you've got something similar to this, it needs to be something that seals. So the ones that don't have a seal on them are not going to work. But if you have a plastic or glass jar, that should also work. It's just going to be a lot easier to do this with a little plastic Ziploc baggie. If you don't have one at home, feel free to stop by the library and I can get you one. And then the other thing that you are going to need is just a Sharpie or a dry erase marker. And that's going to be for making marks on your bag. And there's only one other thing that you could possibly need for this, and that is going to be food coloring. But I am not using that, and it is optional. That's going to make your water look more oceany. All right, so what you're going to do is take your Ziploc bag, and you're going to practice your artistic skills. This is putting the A in STEAM. All right, so I'm going to draw a little ocean scene here. So you're going to start by drawing, and I am not a great artist, and that's okay. All right, right there you can see that is my ocean, but that's a pretty boring scene right there. I feel like we need to have some other stuff in there. So let's draw some beautiful, beautiful clouds. Sure, that looks mostly like a cloud. Let's give us some different kinds of clouds. All right, look at that. I drew a few clouds, but what kind of scene is going to be complete without drawing a nice little sun in the corner too? So there's my sun, but that's kind of boring. So I feel like when you draw sun, it's nice to draw some rays. I know that there's not really the rays when you can see them, but it helps people to see what you're talking about. So look at that. But what kind of scene is this without a little bit of animals going around? So I'm going to draw my favorite thing, some seagulls. You know, when I was a kid, whenever I drew a picture, my signature on it was actually 3 seagulls. You can look at all of my old art projects and check to see that. So look at that. I drew some seagulls flying through the air. The reason that I like them is they're literally just an arch, another arch. All right, and then let's draw some fishes. All right, so I'm curious how many people heard me say fishes and got annoyed. So I will tell you, if you've gotten into an argument of what the plural of fish is, it's fish and fishes. Both of the answers are right. I know that's annoying, but it's true. And fish are pretty easy too. It's basically if you make a figure 8, if you know how to do one of those, but one of the ends of them you make straight up and down instead of curved. And that's all you need to do to make a lovely, simple drawing of a fish. And then if you want, you can add an eye or a little mouth. I'll give all my fish an eye, why not? So there you go. Got some fish, but those are all kind of the same ones. So I think, ooh, let's see if I can draw anything that. So I like sharks, so I'm going to draw a shark, but I don't really have the artistic skills to draw a shark, so I got a little shark right at the bottom of there. We can pretend that's what that is. All right, so that is what you need. So I would say get creative decorating your bag. Just have fun with that. All right, so now this is probably one of the simplest experiments that we've done in here. You're going to open up your bag, and where you drew that line for being your ocean, you're going to pour in some water. And I'm just going to pour right from my water bottle here. And then just pour your water to wherever you had your line for water. You'll want to make it somewhat near the bottom. Let's see here. And it doesn't need to be right on your line, but close to it and it'll look a little nicer. So this is where you'd use the food coloring if you like. So right here, there is, you can still see all my fish in there. So if you wanted to, you could grab some food coloring. And you'll need, let's see here, trying to get away from me. Oh, wow. All right, so what you'll need is blue food coloring, but if you want it to be really authentic, you'll try to get just a tiny amount of that. So maybe 2 drops of blue, and if you could try to do less than a drop of green, then you're going to get a pretty authentic ocean color. But if you can't manage that, I'd say just do 1 or 2 drops of blue, and it'll get nice and pretty in there. So now that you've got your lovely scene here, the only thing left for you to do is to take some tape and tape it to a window. So make sure this is a window that is facing outside, and you'll want to tape it up so that you can see your scene that you've drawn on it. And then you'll just take some tape, make sure it's on there steady. Otherwise, remember, you've got a bag full of water and it could fall and plop down on the ground. So just tape it on the top there. And then wait for it to take effect. So this is going to work best on a sunny day. So it doesn't necessarily matter if it's warm, although a warm sunny day is going to be the best that you can hope for. But a cold sunny day will also work. If it's real cloudy, this isn't going to work nearly as well. And just also make sure that you're sealing your bag really well, because you don't want any of the water to escape out. All right, so if you want to be surprised by what happens, and you probably already guessed what's going to happen, some of you, but if not, if you want to be surprised, then you can just pause the video right now, try it yourself, and then you can come back and we can talk about what happened. But for anyone else, then we can just keep watching. So welcome back to anybody who stopped watching the video and then decided to do this themselves and come back. So when you've got this taped up onto your window, the sunlight is going to be shining in on here, and it is going to evaporate the water, and it's going to start going up into the rest of the bag. So what's going to happen is that right now all of the water in this bag is liquid, but it's going to start evaporating, and I'm going to talk about what that means for anybody that doesn't know that. It's going to start evaporating and going into the rest of the bag. So what evaporation means is that it's turning into a gas. So it's turning from a liquid into a gas. So once you've had your bag out into the sun for a while, a lot of the water that was on the bottom is now going to be a gas in the rest of the bag. And you might be thinking to yourself, okay, well, how am I going to know that this is happening? And that's a great question. So the answer to that is the next part of the water cycle. So the first part is liquid water. The next part is it evaporates and goes into the air. And then the part after that is that it turns back into liquid water again. So can anybody tell me what the real world equivalents of those are? All right, and that's okay if you can't think of it right away, but you'll know what I'm talking about when I tell you the answer. So when the water, let's say in the ocean or even in the creek along here in town, that is the liquid water. It evaporates, it goes up into the air, and where does that end up? So part of that's just the humidity in the air, but a large part of that is the clouds. So if you look up, that's what clouds are. Is they are all of the water that's evaporated from the land, and they are now in the air. Now, because clouds are in the air, most people tend to think of them as being light and fluffy, but that's actually not true. So it's important to always remember that air, so all gases, still have a mass. So they have a substance to them. They're a thing. And so anything that's up in those gases also has a mass. It has a substance to it. So it might surprise you to know that clouds can actually weigh hundreds or even thousands of pounds. Every little fluffy cloud you see in the sky, we like to think of them as being like cotton, but they are water and they're very heavy up there, but they're still lighter than the air around it. You actually have thousands of pounds of air pressing on you all the time, but you don't notice it because it's on all sides. All right, so now that you know that the second part of the water cycle is clouds, and that's the gassy part of air, what do you think the next part is? All right, so if you said rain, you are absolutely right. So the water is now going to turn solid when it falls down from the clouds. And that is how you're going to see the water cycle in here. Now you might be saying to me, well, Zach, I don't think it's actually going to rain inside this. And you're partially right on that. So you're not going to see drops of rain just falling from in here. You're not going to have a teeny tiny little version of rain. But what you are going to see is the vapor is going to condense. So condense is short for condensation. And that is when a gas turns into a liquid. All right, so The water, let's go over that again. The water is going to turn from a solid, or sorry, not a solid, a liquid in this just water form. It's going to evaporate and it's going to be a gas, just like the clouds up in the sky. And then it's going to turn into a liquid again. Sorry, I keep saying solid. I feel like I've said that a couple times. It's going to turn back into a liquid again. And that is going to then be on the sides of this, and you're going to see it run down. So if you put this in your window for the afternoon, you're going to start seeing this. I would recommend leaving it for a couple days, and you'll actually be able to see it play out multiple times. If you leave this for a week, you're going to see it's probably going to rain a few times. Alrighty, so there's another really important concept that we've got going on here inside this bag. So this bag is a plastic film, and it is going to let in the light of that sun. And light isn't just light. Light, and I'm gonna, here we go. So I'm gonna pause real quick to show you this. All right, so always be careful. All right, so it's not quite a rolling boil yet, but you can already see that it's starting to steam. So that boiling water on the stove works the same way as it does when the water is evaporating. So you can still see it back there, as the water is just evaporating. So it's turning into steam up there. And if we were working on a larger system than just this pot of water, that would turn into clouds. And actually, some of this steam, if it leaves the building, will continue to go up into the air and can turn into clouds. So there's a very real possibility that this water I'm boiling right now, a little bit of this might fall on your head as a raindrop, or given the time of year it is when I'm recording this, as a snowflake. All right, so you might have already noticed something, what I was getting at before with sunlight, but also, why is this turning to steam behind me? You might already know the answer is heat. And it's actually going to be the same way when water evaporates here anywhere on Earth or beyond. So what happens is that the sunlight is going into this bag or on a river or an ocean, and it's the heat from the sunlight and the rays of sun that are heating up the water and causing it to evaporate. Now you can have things evaporate without things really getting hot. And that's because the rays of the sun are going to be affecting parts of the water. It's not necessarily heating the whole thing up to boiling. The water doesn't have to boil to evaporate. And you'll notice that if you've got a pool full of water and it doesn't rain, eventually, if it's sunny, it's going to all evaporate, even though the water's not going to get especially hot. Certainly not boiling. I would hope that if you've got a pool, your water's not boiling. All right, so I hope that you follow along with this activity and make your own water cycle. All right, so those are the simple water cycle. You've got the water, it evaporates, becomes clouds, and then rains down. And I've said rain this whole time, but it's just any time that water is falling, whether it is liquid like rain or whether it's a solid like sleet or snow. So snow is just as much a part of this water cycle as anything else. It's going to be coming down along with it. All right, so there's a couple other parts of the water cycle too. So you might have already been thinking, well, Zach, I know there's other forms of water. I mean, you even said there's the liquid, there's the gas, and there's the solid. You mentioned ice. What about ice? And that's a great point. Ice is a huge part of the water cycle on Earth too. But being in Iowa, we tend not to think about that except during the winter. So in the winter, we get solid water or ice as snow. So snowflakes are little ice crystals, and those will build up. The biggest part of the water cycle that snow and ice does is it takes some of that and it concentrates it in one area. So just like a river or a lake is a concentrated water, whereas if it's in the sky, it's spread out more, it's going to be concentrated. So if you don't know, concentrated is put together in a tight area. It's going to be concentrated if it's snow and ice as well. So the biggest example that you can think of is that icebergs and ice caps. So when I say iceberg, I think a lot of people think of the Titanic or the Arctic, things like that. But whatever you think of, it's huge, huge blocks of ice. And you've probably heard about them in the news because they're melting a lot quicker than they have in the past. And so that's actually a big thing of why our water cycle is changing right now. You might have noticed that some areas are a lot drier than they used to be. You might hear your parents talk about that. So that's a big reason. The water cycle has shifted because of that. All right, but yeah, so solids are an important step in the water cycle as well. So some of the water from here, actually, a lot of people picture whenever water evaporates, still going? Oh yeah, that's still going well. Whenever water evaporates, I think people assume that that water is just going to fall back on the same area, but that's not really how it works. So if I've got a pool of water in my yard and it evaporates from here in Iowa, there's a very real chance that that could fall just anywhere else in the world if those clouds get pushed to other areas. So eventually my water is going to make its way to Antarctica, to Egypt, all over the world, wherever you pick. So the water cycle gets things moving around. All right, so before we go farther, I want to give you a couple of book recommendations here. So we've got some really good books on the water cycle here at the library. All right, so the first one I want to recommend here is Rivers of Sunlight. So how the sun moves water around the earth. And this one is a fantastic introduction to the water cycle. I would highly recommend it. It's got some just brilliant illustrations in it, and it tells you all of the ways that water moves. It's going to talk about some sort of things that I haven't talked about in here too, some different ways that water can be in very specific ways. So I'll let you read that if you want to. This is a very good one. All right, so if you want another good introduction to the water cycle, or if you wanted to dive just a little bit deeper, then I would recommend The Magic School Bus, Wet All Over. So if you are like me, you love The Magic School Bus. I grew up on this, the books and the show. And so this is a very good introduction to the water cycle. It's got some great illustrations. The kids in this one actually become parts of the water cycle. So they get evaporated and they become the clouds. It's very fun. All right, so I mentioned that the water cycle, we tend to focus on rain when we talk about it, but snow is just as important, and I know that's coming up here in Iowa. So this one is The Snowflake, a water cycle story. This is another really fun one. It's got just gorgeous illustrations in it, almost woodblock style, if you know what that means. And this one shows step by step what happens to a little drop of water as it goes through the cycle and becomes a snowflake and beyond. It is such a fun story. All right, so if you are interested in the water cycle, you're probably interested in weather in general, and I've got a great book on all things weather, and that one is an eyewitness book, Weather. And this one just tells you all sorts of things that are fun to learn about weather. Tornadoes, wind, monsoons, rain, the science of weather, weather in mountains, lots of fun stuff. All right, if you're interested in how water moves, which I'd hope if you're listening to me talk it still at this point that you are, then I've got another interesting one for you. So this one is called Tracking Trash. It is Flotsam, Jetsam, and the Science of Ocean Motion. So flotsam and jetsam basically are the things that get left behind or ejected out of ships, out of boats. And this one is basically tells you all about how trash moves in the oceans. And if you read this, you're going to really understand how the movement of oceans works a lot better. This one is very good. I will give you the warning, though, for content. It is a little bit sad. You probably can guess that, seeing just the seal caught in a net right there. But fantastic book. You'll learn a lot reading this one. It's kind of amazing how much trash is in the ocean. Which, by the way, in just 30 short years, scientists are now saying that there will be more plastic in the ocean than fish. So we have that to look forward to if we don't do something a little bit different there. All right, so let's see this. I don't quite have this at a rolling boil yet, but I think this is a nice background. Look at that lovely steam. Coming out as water now. All right, so, and just remember, that is a mini version of the water cycle, just as this is, because it is the heat energy that is changing its form. So when you're talking about solids, liquids, and gases, it's always going to be heat is what the thing is that changes them from their states. So a solid is always the coldest one. And then when you get a little warmer, it's a liquid. And then when you get warmer than that, it's a gas. So just think about ice all the way to steam. So if I've got this water, if I want to turn it into a gas, what do I need to do? That's right. I need to heat it up. But if I want to turn it into a solid, what do I need to do now? Perfect. I need to freeze it. I need to make it colder. And so that's the way it's going to work with all sorts of things. So any material you have is going to have a point, well, for the most part, there's a couple exceptions. So for the most part, any material you have, if you heat it up or cool it down, it can turn into different things. So even this food coloring, if I were to freeze this, it could turn into a solid. Or what's another good example here? This pen is made out of plastic. If I wanted to, I could melt this and turn that into a liquid by adding more heat. And if I added even more heat to it, I'd turn it into a gas. I would not recommend doing that because it is actually very dangerous to heat plastics up to the point of them becoming a gas. All right, but the most interesting thing I think with adding heat and this is that it all boils down to motion of the atoms. So everything in it is made up of atoms, little teeny tiny particles. And I'm not going to get too much into that because that can take too long to go through. But basically what happens is heat adds energy to the little particles and makes them move faster. So this water is more active. The particles in it, they're moving around more than if it were solid. So particles in everything are always moving around, even if they're a solid. So even in something like this, the atoms are moving around against each other. Now, the more solid something is, the slower they're going. So the more heat you add to a system, so to an object or an environment, the faster those molecules are going to go. And that's actually where, if you've ever heard the phrase absolute zero, I think that's a really cool concept. So 0 degrees, if you are in Fahrenheit or Celsius, gets used for different things. So 0 degrees Celsius is where water turns into ice. 0 degrees Fahrenheit is a little bit confusing. It's where it's confusing. It's where a slurry of ice, water, and I believe salt changes states. I think Celsius actually makes a lot more sense. But we mostly use Fahrenheit here in the US. But those are just a relative thing. But if you use Kelvin, I think is the coolest way to measure temperatures. And I encourage everybody to look that up. So if you have 0 degrees Kelvin, that means there's no heat at all. So if I've got 0 degrees, as you know, living in Iowa, it can always get colder than 0 degrees Fahrenheit. Same thing's true for Celsius. But if you get to 0 degrees Kelvin, you can't get any colder. Now, it's pretty hard to get that cold. So if you go into space, if you were to travel a long, long ways, light years away from our sun, it'd still probably be 2 or 3 degrees Kelvin. It's hard to get that cold. And here on Earth, I can't remember what we've gotten to. We've gotten it pretty cold, but that's only in laboratories. All right. There are some places even in our solar system that are very cold though. If you go to the parts of the moon that are continually in shadow, I believe those only get to tens of degrees. And to put that into perspective, 0 degrees Kelvin is, let's see if I remember right, I believe 273 degrees negative in Celsius. So it's very, very, very cold. Now, I've got a fun thing for temperatures as well. I have actually been outside in the temperature where Fahrenheit and Celsius are the same. So these are different scales, but there is one temperature where they meet up and it's the same temperature, and that's negative 40 degrees. So negative 40 degrees is the same whether you're saying Fahrenheit or Celsius. And I was camping then. So I know some of the people here are going to think that that is an absolutely insane thing to do. It was a fun experience, but the reason I bring this up, first of all, I think that's really cool that that just happens to be the point where they, so converge is the scientific word, the point where they meet at the same point coming from different places. Converge is a great vocab word. But also that was cold enough. I was camping in a tent that my breath actually demonstrated to me the water cycle. So when you breathe out, there's always little droplets of air or droplets of water that are attached to the air you're breathing out. That's actually why everybody keeps talking about masks. That's the whole reason behind it, is those little droplets. But those droplets are airborne, so they are a gas there, and they are in the air, but it was cold enough for me in there that overnight, those little droplets froze in the air, and then it snowed on top of me inside my tent. So I'm guessing most people have never actually been in a place where it snowed on them inside, but I have, and it is weird. So if anybody wants to hear more about that, I'd be happy to talk about that if you ever stop in the library. Alrighty, so the other neat thing that I think is fun about the ways that things can change state. So remember, if you add heat to ice, it will turn into water. But that's not the only thing it can do. So I've got a question for you. Have you ever filled an ice cube tray and then put it in your freezer and then noticed if you leave it in there a long time, you eventually have less ice than you had before? So I'm not talking about how, so if you put water in the freezer and then let it freeze, it's actually going to get larger than it was when it was water when it becomes ice. And that's because ice expands. It's actually, water is one of the very few substances that when you freeze it, it gets larger. So notice what size and shape it is after it's completely frozen, but then leave it for a while and then come back to it. And eventually you might start to notice that sometimes if you have your freezer at the right temperature, you're going to get your ice cubes smaller than they were before. And that's because evaporation isn't the only way for it to change states. There's other types of things too. So what's happening to your ice is sublimation, I believe, and it is where the ice is turning directly from ice into a gas. And that happens all the time. So you can actually jump straight from solid into gas. And you can see that with quite a few different things that you try. There's a lot of substances that do that a lot easier than others. And my absolute favorite one, and I'm sure that some of you have seen this too, is dry ice. That is exactly how dry ice works. So you might have noticed if you've got a block of dry ice, it changes directly from a solid into a gas. You'll notice you don't have liquid dry ice. And that's what happens because it's rapidly turning from a solid into a gas and it's jumping straight to that. It can also happen the other way. Things can turn directly from a gas into a solid. That's what happened with my snowflakes when I was in a tent. So I just think that's neat. It's not just that linear cycle, and so linear means going in one direction. It can jump all the way across the board. All right, so I'm going to show you one more thing that I think is really important to know about water cycles. So I talked about how the water can get trapped in ice in certain areas, and then it can also pool into things like rivers and lakes. But there's one more thing, and this actually comes as a request of a patron who I told I was doing a video on the water cycle. They wanted me to talk about groundwater, and I said that's a great idea. So I've got this jar full of dirt. Now you might actually recognize this because this is the same jar of dirt I've had in the previous video. And it is different layers of dirt. It is very dry. I have not added any water to this in quite some time. And here I've just got my water bottle. So I'm going to pour some water in this, and we'll say this is simulating rain over a long period of time. All right. So right now you can see it's just on the top. You can tell mostly from the way the water has changed the color to a darker color on there. I'm going to add more because it's so dry that this has absorbed the whole thing. I'm going to need quite a bit more. So right now it's acting like a lake, or mostly really like a swamp. Now, can you see those bubbles? That's actually because this ground is dry and air is escaping from down here, but it's saturated so much up here that it's having a hard time getting out. So this might go a little bit slowly. All right, here we go. Now it's starting to go. Gotta add more here. Doesn't that look appetizing? No. All right. So this is going to take just a little bit for it to absorb. And if you want to follow along with this, that's easy. You just need a jar and some dirt and some water. Here we go. All right. So you might not be able to see this incredibly well on your video. Yep, you can see some big bubbles in there now. But I had a little pocket down here of the dirt that I wasn't filled in. It had a bit of an air pocket in there. And when I poured this water, it's settling into there. Now this is showing you the basics of what happens when water accumulates underground. So we're usually used to seeing water above ground in our rivers and your lakes that we're used to, but underground there is also water. And so there we go. If you look into there, you can see that this area right here is just solid water and around it is dirt. So that's what happens here. Now, who here gets their water from a well? So I'm guessing there's a few people watching this that do, just given the area that we're in. So that is what well water is. That is water that is trapped underground. So it is trapped underneath the soil and the loam, which is going to keep it underground. It's not going to be evaporated nearly as easily. So if water keeps accumulating and keeps raining down on my soil here, you can see it just keeps filling up that area. Now, usually this doesn't happen that there's just giant or little pockets of air that get filled up. There are definitely some pockets of air that end up getting filled by water, but what also happens is that water can just accumulate and it can just take up a space in there, and then it can just keep forming larger pools that wears away at things. But it's also important to know that's not the only thing that can accumulate underground. This is exactly the same type of thing, well, almost exactly the same type of thing that happens with oil underground. So it's not raining oil from the sky. If that ever happens, I'd be a little bit concerned. But oil is collecting underground in a very similar way. It is on there. And so whether it's oil or whether it's water, people drill down into it and then bring it to the surface. So well water tends to be, let's say this is underground. So you've got a little person up here. Well water tends to be right here. But sometimes you'll drill a different kind of well much farther down, and you're getting water from there. All right, so you might have noticed here, I'm pouring water in here. But any liquid that falls on the surface can get down into here and go into what's called an aquifer, and that's where that water is being stored. So let's say I have this green food coloring. What if that's something else? Say this is something that somebody dumps in a river and then it runs off, or this is something that somebody puts in a field. So if you've got, say, a field right over here and then the water is running down, it's these food colorings here. You know, I'm not going to do green. I think I'm going to do a different color so it shows up just a little bit better. Ooh. Too excited about that. Wanted to jump out at me, that food coloring. Yeah, I think red might. Yeah, I'll try a couple different food colorings to see how they go. So let's try some red. Put that in here. And you might not be able to see it real well on here, but you'll be able to see soon. So let's say there's a farmer in this field, they've sprayed something, and it gets in the ground here, and then it rains some more. That washes it down. Oh, I can already see the red. All right, so then I've also got some green. Let's say that's somebody who just dumped something in the storm drain. And then this is starting to get pretty saturated, so I don't know how much more. I probably should have saved some of this water. And it rains again. I'm going to wait for it to bubble up a little bit. And now you can see. I'm going to shake it just a little bit, otherwise it'll take a little too long to get down there. So right about there is where most people would drill a well, and I can already tell it is red water in there. So I'm going to grab something else to show you here. All right, so I don't know why I grabbed the red one. All right, so let's give it a little bit more rain. Rain, rain, rain. That's going to wash it down into the aquifer, and you're going to be pulling your water out of there. So many cities actually get their water directly from underground wells. So everybody's water has to come from somewhere, and a lot of times it's going to come from underground aquifers. It'll either come from that, or it could come from lakes or streams, but they're getting it from somewhere. Even if they're processing it in a factory, it's coming from somewhere. So this is my well, and I'm going to stick it down into the soil. Bloop. I'm going to stick it far enough down into this pocket of water right here. I'll probably, because it wasn't too large of a pocket, going to get a little bit of soil. Yep, here we go. Move that to the side a little bit so I can get a little more pure stuff instead of some soil. But all right, I missed my thing again. Clearly, I'm not a professional well driller if I didn't get it on my first try here. All right. So let's get it. All right. So I did get a little bit of dirt in there, but you should be able to see. So if I had taken a sample of this before I put in the food coloring, it would have been clear water, minus just a tiny bit of mud because I didn't do it perfectly. But now you can see this is red. So everything that got run off into this groundwater is in there now. So this is then whatever the substances that got pushed by the rain into the thing, this is going to be in what you drink now. This is why you'll hear people talking about sometimes things like lawn treatments, especially, are a big one. When you see those signs on people's lawns, it means they've put chemicals into it that then get washed off of the street into the storm drains, and then those enter the water system. And sometimes those will enter into a water system that people take directly for their drinking water. Now, if you're getting your water from a river, most of the time it's going to be treated and these types of things are removed. But if you're getting your water from a well water, until these types of things go into your well water, you can just drink straight from a well. That's why well water is so good. And if you haven't tried well water before, I would recommend going to somebody's house who has a well, because you're going to notice their water tastes different than what you get here in the city. And that actually has to do with little traces of different types of metals and other minerals in them. It's really neat. All right, but so you can see this water is what you would in the business of water treatment call contaminated. So depending on what it is that ran off into the water, this could no longer be safe to drink from all the water in that well. So thank you, the person who asked me to talk a little bit about groundwater. There is so much more to talk about with groundwater, and so I have not talked about everything for that, but just a little brief introduction to how that works, I think, is pretty neat. So now you can see I have probably permanently stained this soil an odd shade of red. So if you do this, I have another fun experiment for you to try. Try planting something in this water with food coloring. There are actually quite a few plants that if you put food coloring in their water, they will turn that color. A lot of, if you've got a white flower, some of them will change the color of the flower to whatever was in that food coloring. It's pretty neat. Alrighty, so remember today we talked about the water cycle. We learned a lot today about how the water cycle works, how things evaporate and change forms. You can still see this lovely water right here. Alrighty, so look at that beautiful steam. So how is that working again? All right, so remember, this is heat being added to the liquid water, turning it into a different form, and that is steam, and that's the gas form of water. So whether you call it steam or vapor or gas, that's what's happening to it right here. Alrighty, so thank you so much everybody for joining me. Again, my name is Zach. I am coming at you from Hudson Public Library in Hudson, Iowa. Thank you for joining me for this week's Science Explosion, theme of water. And next week, we're going to be talking about rocks and mountains. So I hope I see you then. Thank you. Bye.